Alright, so the whole reason of logarithms, remember, is to essentially solve exponential equations. Right? And we'll do some examples with some real life applications here as well, but this is kind of how I started this entire unit. Okay? It will be a problem like this. 6 raised to the x plus 2 power equals 21. In order to solve this type of equation, I would logarithm both sides. Now, because I have logarithms, I can take this exponent, x plus 2, and move it out to the front. So now I have x plus 2 times the log of 6 equals the log of 21. And I'm just using common logarithms because that's what my calculator is going to be able to most easiest to use. I can't talk today. Most easily used.
Easiest way.
Yes. Okay? So I move the exponent out to the front. So I have the quantity x plus 2 times the log of 6 equals the log of 21. I would divide both sides by the log of 6. Now I would finally go to my calculator, take the log of 21, close my parentheses, divide it by the log of 6, close my parentheses, press enter, get that answer, and subtract 2. And to about 3 decimal places, if I could use just a little bit of help on that, or I guess I got one here too.
Looks like we're getting 1.699.
Okay, any confirmation from
That's what I
just a
got.
second?
That's what I got.
Okay, 1.699. Not,
Still right.
and that 9 will not go up.
That was not.
That was
not
just for the
the
log
ex-
21 divided by log 6.
Oh.
That's not the minus 2
So
yet.
the real
I
answer
already-
is negative.
Lexi, I wrote
Negative
that
0.3.
I was just
Negative
doing
0.
0.3.
0.3. Negative 0.3 is what we're rocking right now.
And even the 3 decimal places, it would still be 0.300.
0 or 0.1.
It would be 1.
301
Never mind.
technically.
Why?
Okay.
Wait till he writes the final answer.
Alright, so approximately negative 0.301.
Yes.
You could always take that, substitute it back in, take negative 0.301, add 2, get that answer, take 6 raised to that answer, and hopefully it equals really, really, really close to 21. Why would it not be exactly 21?
We rounded.
We rounded right here.
Will we get in trouble if we don't put the squiggle mark?
No, that's just a thing that I do because it's not exact.
Alright.
Okay? Alright?
Yes.
Okay? How about this? 3 to the x plus 1 equals 5 to the x.
Oh,
Ideas?
Log
Log
both
both
sides.
sides, because when you got a variable up in the power, you just log both sides, because as soon as you log both sides, you can move that variable that's up in the power out to the front. I'm going to do it all in one step. X plus 1 times the log of 3 equals x times the log of 5.
divide by log of 3.
I don't want to.
Divide by x.
You don't want to.
I distribute
Let
x log 3 plus log 3 equals x log 5. Dividing by x would maybe get rid of the x here, but now you'd have x plus 1 over x here. And I don't really want to solve for x when it's in the denominator. Dividing by log 3 would have gotten this x plus 1 by itself, but then I would have had x times log 5 over log 3. Which that isn't terrible. You could then see what log 5 divided by log 3 actually is, but you remember that still has an x on it. I'm going to go ahead and just do it this way. So now I'm going to get all my x's onto one side. So I'm going to move this x over here. So So log 3 equals x log 5 minus x log 3.
And you can take out the X.
I'm going to factor out an x.
I honestly wouldn't have been able to recognize the fact that I needed the factor right there.
You could have figured out what this decimal is, figure out what this decimal is, and subtract them because they're like terms. You'll have so many x here minus so many x here, and then when you subtract them, you still have so many x. I'm just saving yourself the trouble of having to write a whole bunch of decimal places out because I don't ever want you to round till the very end. That's what this is doing for you. But you still could have gotten there had you written out then all those decimal places. Now I divide both sides by this quantity to get x by itself. So I'm going to divide by the quantity log 5 minus log 3. Log 5 minus log 3. Let's see how good you are with your parentheses.
Holy heck,
Oh shoot.
this is a bummer.
My
I hope-
answer, but
Okay.
2.151?
yeah.
Yeah.
Really,
Sure.
so fast.
Very quick.
I got that right.
Yeah, me
I
too.
didn't get that.
Make sure on your, did you try doing one step, Faith? Okay. So when you type in, or when you hit the log button, it opens up a parentheses right there before the 3. Make sure you close that parentheses right after the 3. Then you should have hit the division key. Then you should have opened up a new parentheses. So you would have had a parentheses here, and then log parentheses 5 parentheses minus log parentheses 3 parentheses parentheses.
Okay.
Because it needs to know that entire thing is in the denominator, plus you got to stop each parentheses after each logarithm too. Okay? And sometimes you can just put extra parentheses.
I put a ton of
Yeah, I didn't.
I like to do all
Okay.
the parentheses.
So about 2.151. Is this you? Is that your calculator that you were using one day?
Yep, it is. I have a piece of tape on the back. The shots put there,
Okay.
I know it's mine.
Solving exponential equations.
This is Cowdy.
That's okay?
Yeah.
Basically log both sides, use your properties to get x by itself. Okay? I'm going to squeeze in solving log equations as well. Log to the base 4 of 6 plus log to the base 4 of x equals 3. If I were doing this one, I would try and rewrite it as a single logarithm first. Log to the base 4 of, what did I hear you say? 6x, very nice. Equals 3. Then I would change forms. I would change from logarithmic form to exponential form. If this is true, if this equals this, that means that 4 raised to the 3rd power has to equal 6x.
Wait, oh yeah.
Remember?
No.
So then don't we just solve that?
What's the answer to this?
Oh, 2.
Because why?
It's 5 squared is.
Because 5 to this power equals this?
Yep.
The base raised to this number equals this.
Oh, okay.
So that's all I'm doing. I'm just rewriting it. Instead of logarithmic form, I'm writing it in exponential form.
Okay.
So 4 raised to the 3rd power has to equal to 6x. 4 to the 3rd, 64. 64 equals 6x. divide both sides by 6, I get 64 over 6, 32 over 3, right?
Oh. What? I just put a decimal in.
10.6 repeating.
Yep.
Big difference. 32 thirds, 10.6 repeating. 10.7 to the nearest tenth, whatever direction let's say it. Okay, again, now I can write an equal sign if I don't round it. Okay? So log equations.
Feeling okay.
Exponential equations, log equations, okay? I will stop there.